In this lesson, we're going to examine the concept of weighted averages. To understand how the GMAT tests weighted averages, let's start with a sample question. A certain company consists of 60 men and 60 women. The average age of the men is 30 and the average age of the women is 40. What is the average age of all the employees at the company? Now, one way to solve this is to use the ANS table that we've seen in previous situations. We can use the table because the average for the whole is going to be determined by the averages of these two subsets. So we'll set up this table, and in the columns we'll have the respective components of the formula, and in the rows we'll have our subset of men, the subset of women, and then the total set. Now let's input what we know. We know that the average age of the men is 30 and that there are 60 men. So we'll input those values into their respective entries and arrive at a sum of 1,800 for the ages of the men. For women, we know that the average age is 40 and that there are 60 women. So we input those values into their respective entries and arrive at a sum of 2,400 for the ages of the women. And for the total, we don't know the average age of all the employees. That's what we're trying to solve for. So we'll let the average for the total equal A. We know the number of total employees is simply the sum of the number of men and women, so that will equal 120. And we know that the sum of all the ages will be the sum of the ages of the men and the women, which will come out to 4,200. So we'll input those values into their respective entries. And from here, we can create an equation by using this bottom row, where we know average times number equals sum. So we'll create the equation 120A equals 4,200. Divide both sides by 120, and we'll arrive at A equals 35. So the answer here is C, and we got there fairly efficiently. We just set up the table and input the respective values and did our algebra. Now, this question has relevance to weighted averages because it highlights a very important point. Notice that we could have arrived at this answer of 35 much more quickly. How? All we had to do here was average the ages of the men and the women. Simply take the average age of the women, which is 40, add the average age of the men, which is 30, divide by 2, and we arrive at a total average of 35 for all the employees. So in this instance, if we simply average the averages of the ages of the men and the women, we would arrive at the average age of all the employees. Now, we're allowed to do this here because of one very important fact. Notice that the number of men here equals the number of women. In other words, these data points of 30 and 40 have the same frequency. When data points have the same frequency, we can simply average our averages to get the average for the whole. Now, why is this the case? Well, if we look at this visually, it might make more sense. Notice with this little pendulum here, the lower bound is the average age of the men, the upper bound is the average age of the women. Since these data points have the same frequency, the average age for the whole must fall right in the middle to give us a value of 35. Now, questions will not always be this straightforward in the GMAT. This is a very specific situation where the frequencies of the data points are the same. Things get interesting, and the concept of weighted averages applies when the frequencies of the data points changes. In other words, if the number of men was less than the number of women or greater than the number of women, then the average would not fall in the middle of these two averages. It would actually end up being closer to the men or closer to the women. So only if we have the same frequencies of the data points can we average the data points. When that doesn't happen, we're going to have to look at things a little bit differently. So let's look at how we can change this question to apply the concept of weighted average. If we look at this question, notice it's almost identical to the previous one, except for one important difference. Here we're told that the company has 60 men and 240 women, whereas in the previous question, the company had 60 men and 60 women. So in this instance, instead of the number of men and women being the same, we have more women than men. Since there are more women than men, we know that the overall average will be closer to the average age of the women than the average age of the men. Why? Because women are essentially pulling the average closer because there's a greater weight for that subset. And this idea of weight is what really is at the heart of weighted averages. When we're talking about weighted averages, what we're referring to is the fact or situations when the frequency of a data point pulls the average closer to that data point. So in other words, because the data point of 40 appears more than the data point of 30, the overall average will be closer to 40 than to 30. Now, just based on this intuitive understanding of weighted average, we can actually eliminate two choices. We can eliminate choices A and B. Why? Because 35 is in the middle of 30 and 40. 35 is what the average would be if we had the same number of men and women. But here, because we have more women, the average has to be closer to 40 and therefore greater than 35. So just using this intuitive approach, this sort of conceptual understanding of weighted averages, we were able to eliminate two choices. But how would we actually solve here for the average age of all the employees? Now, there are really three approaches to take. Two of them are just based on the simple average approaches we've already talked about. And the third one, the really important one for this lesson, is going to be the weighted averages approach. I'm going to start answering this question by just using the traditional algebraic method where we're going to use a formula, average equals sum divided by number of items. So to solve for the average age of all the employees, we'll want to take the sum of the men's ages plus the sum of the women's ages and divide by the total number of people, which is 300. Now, the sum of the men's ages will be we'll use the formula average times number equals sum to get the sum of the men's ages. And we know that there are 60 men and that their average age is 30. So the sum of the men's ages will be 30 times 60. And for women, we know that the average age is 40 and there are 240 women. So the sum of the women's ages will be 40 times 240. Now from here, if we simplify, we'll arrive at this fraction, simplify further, and we'll arrive at an average age of 38. And so this would take us to an answer of D. Now this approach has not used anything about weighted averages. We simply use the average formula and its variations to arrive at the answer. But one important thing we can do with the original fraction we set up here, I'm going to split the numerator. So now we'll arrive at this sum of 30 times 60 over 300 plus 40 times 240 over 300. And now let's simplify this further and arrive at 30 times 1/5 plus 40 times 4/5, where the 1/5 comes from the fraction of 60 over 300 and the 4/5 comes from the fraction 240 divided by 300. So what's the relevance of the 1/5 and 4/5 here? Well, these refer to the weights of the men and the women. This 1/5 is telling us what proportion of the whole set the men constitute. And the 4/5 tells us what proportion of the whole set the women constitute. So here we have the weights of these two subsets. When we have the weights of the subsets and their averages, we can use the data to determine the weighted average. Now, before we actually dive into the formal weighted average formula, there's an important point to make about the idea of weights. So a weight refers to what proportion of the whole set a subset constitutes. So as we showed here, the weight of the men is 1/5 and the weight of the women is 4/5. Now, we can get to weight in a few ways. If we know the actual frequencies of the data points, that's one way to determine the weights. But we can also get there if we know the percentages. So if we were told 20% of the company was men, 80% of the company was women, we would arrive at the same weights. The weight of the men will be 1/5 and the weight of the women will be 4/5. Similarly, we could determine weights by fractions. If 1/5 was men, 4/5 was women, the weights would again be 1/5 and 4/5. And we can determine weights with ratios. If the ratio men to women was 1:4, again, same idea, then the men would be 1/5 of the whole set and women would be 4/5 of the whole set. So now that we've examined this idea of weight, we can use this to understand how to arrive at a weighted average. The formula for weighted average is the weight of set 1 times the average of set 1 plus the weight of set 2 times the average of set 2, and so on will get us the weighted average. Now, when I say so on, what I mean is there may be 3 subsets or 4 subsets. However many subsets there are, we're going to have to apply the weight of that subset times its average when determining the weighted average of the entire set. So to see how this applies, let's look at a sample question. 200 people attend a certain movie. 80 of the attendees are men, 100 of the attendees are women, and 20 of the attendees are children. If the average age of the men is 25 and the average age of the women is 30 and the average age of the children is 16, what is the average age of all the attendees? So let's first start by determining the weight of these different subsets. When I say the different subsets, what I mean is the men, the women, the children. Each of these subsets composes a proportion of this entire group of attendees. We want to figure out what those proportions are. So first of all, we know that there were 200 total attendees. Now let's figure out what the weight of the men was. We're told that there were 80 men, so to get the weight of the men, we'll take the number of men divided by the total number of attendees, which will give us 80 divided by 200, and reduce to arrive at 2/5. So the weight of the men is 2/5, which means men are 2/5 of the entire group. Now we'll get the weight of the women, and we'll take a similar approach. We know that there were 100 women, so the weight of the women will be 100 over 200, which is 1/2, so half of the attendees were women. And finally, for children, we'll take the number of children divided by the total number of attendees, which will give us 20 over 200, which reduces to 1/10. So the weight of the men is 2/5, the weight of the women is 1/2, the weight of the children is 1/10. Now that we have the weight of the subsets, we can use the averages given to us in the question to determine the weighted average for this entire group. So to get the weighted average, we'll start by getting the weight of the men times the average age of the men. And so the weight of the men is 2/5, and the average age of the men is 25. Now for women, the weight of the women is 1/2, and their average age is 30. And finally for children, the weight of the children is 1/10, and the average age is 16. Now let's simplify, and we'll arrive at 10 plus 15 plus 1.6, which gives us a value of 26.6. So the average age of all the attendees here is 26.6. Now I'm not going to do it out, but we could have used the average equals sum divided by number of items formula to solve here, but that would have become very time consuming. In a situation like this, when you have 3 sets, it's just going to take, it's going to become very inefficient to solve the question that way. Generally, if you see the opportunity to use a weighted average formula in a problem solving question like this, you should make it your goal to actually use it, because it'll generally be the more efficient way to solve the question. Okay, to summarize, weighted averages concern average questions in which the data points have different frequencies. To solve weighted average questions, you can take 2 approaches. Add up the sums of the respective subgroups and divide by the total number of terms, which is the simple standard average method that we've seen in previous lessons. Or the preferred approach, use the weighted average formula, which is the weight of set 1 times the average of set 1, plus the weight of set 2 times the average of set 2, and so on, will equal the weighted average.